Evaluate the following definite integral. The integral between 1 and 4 of 2 times the square root of x dx. So firstly, we can recognise that the square root of x can be written as a rational power. So we can write this as being the integral between 1 and 4. And the 2 can come out the front, and we can say that x to the power of a half is the same as the square root of x. So we can evaluate this integral instead. So the antiderivative of this, x to the power of a half, is x to the power of a half, and then we add 1 to the power, so it becomes 3 divided by 2. And then we divide by the new power, which will be 3 divided by 2. And we've also got the 2 still out the front of all of that. To do the definite integral, we just evaluate it between the terminals 1 and 4. So cleaning up what's inside, we can write this as 2, and then x to the power of 3 on 2 is the same as the square root of x to the power of 3, and then dividing by 3 over 2 is the same as 2 divided by 3, and then we evaluate that between 1 and 4. And just to make our life easy, we can simplify that one step further by taking the 2 and the 3 out. So that's the same as 4 over 3, evaluating the square root of x cubed between 1 and 4. So the fundamental theorem of integral calculus says that that will be the same as 4 over 3 bracket, and then we evaluate what's inside the square bracket between 4, and then subtract away that evaluated at 1. So we'll still have the 4 on 3 out the front, and then evaluating this over here when 4 is in there, that's the same as the square root of 4 to the power of 3, which is 4 to the power of 3 in there, minus the square root of 1 to the power of 3, which is equal to 4 over 3. And then 4 to the power of 3 is the square root of 64, minus the square root of 1, which is equal to 4 over 3, and the square root of 64 is 8, and the square root of 1 is 1, so that's just 7, so it's 4 over 3 times 7, which gives 28 over 3, which is the answer to that definite integral.